morning, ladies and gentlemen. I hope you are doing well and keeping safe during this unusual time, and thank you for coming today. Paper in hand will discuss an innovative combination between weak core strengthening and MBD to drill a very challenging deep water well. And our presentation will start with a general introduction. After that, the basics of weak core strengthening and MBD will be stated. Then the problem statement, drilling plan, and results. And finally, the conclusion. So, in deep water gas field, after years of production, one well got water broke up. So, to compensate the deterioration in the production, we need to drill a new well. But after years of production, the pressure depletion make drilling such well very challenging, conventionally. So we use a combination between the two techniques to make that undrillable well drillable. So there are many weak core strengthening theories and methods, but here we will use the hot stress method. With the weak core strengthening, material is pumped and forced in the fracture opening, creating a bridge which isolate and seal the weak core from the fracture, and then the trapped fluid is filtered to the formation, which increase the compressive strength on the weak core strengthening at the fracture mouth, and leading to increase the frac opening resistance. With MBD, conventionally, the bottom hole pressure consists of the mud weight, the static mud weight, which we prepare on surface, and the annular friction losses, which is added to the bottom hole pressure each time I turn the pump on. And the bottom hole pressure keeps fluctuating from the static bottom hole pressure to the circulating bottom hole pressure each time I turn the pump on and off again. And these fluctuations is okay if the operating window is wide enough to allow so. But what if it's not the case? But in this case, I will correct the formation each time I turn the pump on in this section. And in this section, I will have a losses each time I turn the pump off. I will have a kick each time I turn the pump off. But with MBD, the operating window stays the same, but the ability to keep the bottom hole pressure inside this narrow operating window is improved by the introduction of surface back pressure, which I can alter, increase, decrease very precisely and rapidly from the surface. And now to our case study. We have two challenging sections, the 12¼ by 13½ inch section and the 8½ inch section by 9½ inch section. Firstly, we will drill the regressed sand interpreted with shaded streaks and the limestone ramp in one section, and we will cover it with 10-inch liner for the first time to combine the regressed sand and the ramp, which involved a new challenge, which is the narrow window. In the previous well, we drilled the regressed sand alone and run the liner and cement it, and drill the ramp with the reservoir section. But in this section, in this well, we can't do so, since the reservoir is more regressed after the years of production. So, drilling the 12¼ inch section will be on two stages, two sections, conventional section and MBD section. The conventional section we will use dynamically strengthening the regressed sand till we confirm with the stop of the ramp, then spot a static, a heavy bell stress gauge bell, and let it soak and test the competency of the formation and decided can we continue drilling the ramp without running the contingency liner, or we have to run the contingency liner. And drilling this section was very challenging. We drilled from 4,508 meters to 4,755 meters conventionally, while dynamically stress gauging and strengthening the formation while drilling. by loading the active mud system by stress gauge materials with a concentration of 19 pounds per barrel. After confirming, during this section we had a high level of gas, up to 20%. So we stopped drilling, we lowered the downhole pump rate, and continued drilling, adding connection when the gas level come to acceptable level 4%, 5%. After confirming the ramp top, we spotted a heavy bill, a stress gauge heavy bill of 645 barrels with a concentration of 29 pounds per barrel of stress gauge material, and let it soak and performed FIP. It results in 15.05 ppg, which is lower than the expected value of 15.25, which worsened the situation. But we put our bid on the MPD that he can get us through the ramp. We drilled with MPD the pressure ramp from to 5,000 to 4,500 4,663, and while drilling the upper section of the ramp, we got a high level of background gas, slight background that's actually kicked up to 50% of the gas. So we stopped drilling, we diverted the flow to the mud gas separator, circulate until we reached the 5 to 7. And then at the depth of 5,633, we got losses of 70 barrel per hour. So we followed the agreed on procedure. We bumped the LCM bill, but however, the losses increased to 250 barrel per hour. We decreased the ECD using the MPD to 14.8 instead of 14.9. The losses decreased to 230 barrel per hour. So we bypassed the MPD choke. We only have surface cut pressure of 50 psi. The losses decreased to 150 barrel per hour, and then decreased to 60 barrel per hour. We continued drilling till at the depth of 5,755. We got we decided to reduce the ECD even lower to stop the losses. We was drilling with losses. We decreased the losses, the ECD to 14.767. The losses stopped, but we got gas up to 30%. So at this moment, we had no margin between the pour and frac. Since we observed losses at 14.7679, and the pour pressure was 14.95. So to reduce the ECD more than that, we have to reduce the downhole pump, which will jeopardize and compromise the wellbore cleaning. So we decided to call the section TD and run the liner at this level. Now the 5.5 inch section by 9.5 inch section. This section is drilled through the depleted reservoir. We decided to dynamically strengthen the formation while using MPD. We drilled the section to the section TD, keeping a bottom hole pressure of ECD of 14.6. We drilled section eventless using the MPD in a semi-mode, which is surface maturation. We're gonna explain the two different used mode in the next slides. And we drill it to the section TD, and we run the liner and perform the cement job using the MPD. And here's a connection performed at the first section. That's a C mode. We have 3 MPD modes. We have the auto mode, which is the manual shock react dynamically to follow the model, the model I entered to keep a certain bottom hole pressure at the anchor point, and we didn't use this mode. We used the first mode is the C mode, which is the connection mode, where the MBD choke follow a preset table of surface tank pressure with flow rate to keep the bottom hole pressure equal or a little bit less than the drilling ECD. And as we see, we were starting 14.93, and as we see represented by the green lines, the difference between the highest and lowest ECD performed or imposed on the formation while the connection is 0.09 ppg, which is 70 psi. And here's the MBD connection in surface tank pressure mode. And we kept while the connection 14.5 ppg with surface tank pressure of 620 psi the whole time, the whole connection time. And now to the conclusion, the application or the combination between the weak core strengthening and MBD was successful and enabled the following. In the first section, we drilled the regress sand and the pressure ram, limestone pressure ram in one section to the casing depths, and we successfully run the section, the liner with no problem. We also eliminated the need for 12 3/4 liner, contingency liner, by mitigating the well control event potential and the severe losses. We performed FIT to validate the pressure portfolio, and we also mitigated the losses at the end of the 12 1/4 section, where we has a bleeding formation down in the hole, and we have weak sands up there. So to regain the control, we have increased the pressure at the bleeding formation without increasing the show pressure at the weak sands. So we used the MBD to spot a heavy bill of 350 barrels of 15.5 ppg, to spot it in the open hole while keeping the shoe pressure constant. And that's, we can't do that without MBD. In the 8.5 inch section, the MBD increased the chance of strengthening success, where it lower or decrease the fraction opening, which contribute in the success of the stress gauging job. Also, the MBD system at the 8.5 inch section successfully drilled through a very narrow window of 0.3 ppg from 14.5 to 14.8 ppg. Also, with MBD we accomplished, or it enabled us a better zonal isolation, where we used it to run and cement the liner, imposing lower ECD on the formation. And it's also decreased the wheel stability issues and differential sticking, despite the high overbalance between the mud and the regressed or the depleted reservoir. It was 3,600 psi overbalance. And that's all for me. Thank you so much for listening, and now it's question time.